So the next group of lectures is going to be about double bonds and what do we do when we have multiple double bonds in a structure and how do they react? Are they going to react as a single double bond or are they going to react as, are they going to kind of talk to each other and react as a network? And what we're going to see is, of course, that the answer is it depends. So what I want to the first thing we want to define is we want to define what is a conjugated system. Conjugated systems are going to be the things that we're going to talk about for quite a while here, and they have a little bit different reactivity than we would otherwise notice. So the alkenes that we know so far, or the alkenes that we've talked about so far, right? If you have something like butene, this is just a regular old alkene. We don't need a special name for that. We've already talked about that. The other thing you can have is you can have double bond. You can have multiple double bonds in a molecule, but they can be kind of separated from each other, removed from each other. These we would call unconjugated alkenes. Right? And notice that the reason that they're unconjugated alkenes here is because we have sp3 carbons between the double bonds. But we could also set these double bonds up so that there are no sp3 carbons between them. And if we put a double bond here, and a double bond here, right? In this case, there are no sp3 carbons in between. And this is what we call a conjugated system. These are conjugated alkenes. Okay. Now, why do we draw this distinction between unconjugated and conjugated systems? And the reasoning there is that remember that when we have sp3 carbons, neutral sp3 carbons in between things, that cuts down on the resonance that we are able to do, right? If we make a carbocation at a position, at one of these two positions, right? So let's say that we take this unconjugated alkene and treat it with acid. Right? We make the carbocation on the more substituted carbon, right? We add the hydrogen here. This carbocation can't really react with this double bond. The pi electrons here can't share with this carbocation, and there's no resonance stabilization here. Stabilization. However, if we look at the conjugated system, of course, resonance will be possible. Add H plus to that thing, and we get something that looks like this. So we get a resonance. Resonance is possible, right? Resonance stabilized. This is a much more stable carbocation, right? We can move the pi bond over here and get a resonance structure that looks like this. And so conjugated systems have this possibility of this additional resonance form, or not only a possibility, but the existence of this additional resonance form. When we react one of the pi bonds, the other pi bond also gets involved. And so when we talk about conjugated alkenes, we have to treat the whole thing as one system. Now, conjugated alkenes always have the same pattern, right? You're always going to have this pattern of double bond, single bond, double bond, right? Like we have here. We have double bond, single bond, double bond. We can look at some other examples that are not conjugated systems. The unconjugated alkene up there is, of course, a great example. You can also have double bonds that are too close to each other, right? So if you have a carbon here that's has a double bond coming off it in both directions, this is also an unconjugated alkene. These are unconjugated. This functional group actually has a name. It's called an allene. But the reason that we call this unconjugated is because if we make a carbocation, we cannot get resonance stabilization of the cation, right? If we react this pi bond with H plus, we're going to make the carbocation. Let's do that really quick just to drive the point home. If we react this with H plus, we're going to get this carbocation, but that carbocation cannot be resonance stabilized. In fact, that's a really terrible carbocation. So unstable and no resonance. And so allenes have a very different chemistry than conjugated systems. So conjugated systems need to have this pattern of a double bond connected to a single bond connected to a double bond. You must have this single bond in between so that when you generate your cation or whatever, you can move the pi bond over and have that resonance stabilization.